Okay, this is the first video of, I think, 9 sets of notes that we said we were going to do. And it's the intro to related rates and the related rates notes. They actually go together. And really all related rates are, it's implicit differentiation with respect to time. Now if we go back a little bit, the definition of a derivative is that it's the slope of the tangent line to a curve at a point. But slope is the same thing as the rate of change. So with that in mind, we start with the intro to related rates notes. Questions 1 through 4 tell you to translate the following into calculus notation. Well, the first one is telling you the volume of a cylinder is increasing at a rate of 6 cubic feet per second. So really what it's asking you is find the rate of change of the volume with respect to time, and that's going to be, since it's increasing, it's positive 6 feet cubed per second. And that's it. That's it for number 1. Question 2 is telling us the depth of water in a rectangular pool is decreasing at a rate of 2 inches per hour. So now you're looking at the rate of the height with respect to time. Since it's decreasing, it's negative 2 inches per hour. The third one. At rush hour, the number of vehicles going through the SunPass toll booth is increasing at a rate of 85 vehicles per hour. So the rate of change of the vehicles per with respect to time is 85 vehicles per hour. The fourth one. Air is escaping from a spherical balloon at a rate of 15 cubic centimeters per second. So the rate of change of the volume with respect to time is, since it's escaping, it's got to be negative. So negative 15 cubic centimeters per second. And that's it for questions 1 through 4. Now, 5 through 14 is telling you take the derivative with respect to time. Remember to consider which variables change with respect to time before you take the derivative. So, question 5 says the area of a triangle, not a triangle, of a rectangle, is A equals length times width. Well, on the left side, if you take the derivative with respect to time, it's just dA over dt. The right side, that's the product rule, which is the first times derivative of the second plus the second times derivative of the first. And that's what you would need for question 5. 6, you're given the formula for the circumference of a circle. Take the derivative on the left. Remember that 2 pi is just a constant, so really the derivative of r is just going to be 2 pi dr dt. For 7, you're given the volume of a cube. Left derivative is dv over dt will equal 3s squared ds dt. 8, you're given the lateral surface area of a cylinder. 2 pi is just a constant, so you have ds over dt equals, take out the constant, and you're left with a product rule. So first times derivative of the second plus the second times derivative of the first. For 9, you're given the area of a circle. If you derivative of the left, take out the constant, derivative of what's left over is 2r dr dt. Let me erase all of these. I'll start at the top. 10, you're given the perimeter of a square. So dp over dt is equal to 4 ds dt. 11, you're given the volume of a cylinder. Take out the constant. Well, first take the derivative on the left, and you're left with a product rule. So first times derivative of the second plus the second times derivative of the first. Question 12, volume of a cone. dv over dt, take out the constants, and again you got a product rule, which is exactly the same as question 11. So first times derivative of the second plus the second times derivative of the first. 13 is the volume of a sphere. So dv dt equals 4 pi thirds. And really there's no product rule there, so that's really just 3 r squared dr dt. You can simplify the 3's because they will cancel out. One's on top, one's on bottom. And you're left with 4 pi r squared excuse me, dr dt. You don't have to simplify, but you can if you feel that it makes it easier. And the last one is the side lengths of a triangle. X squared plus y squared is equal to 25. So 2x dx dt plus 2y dy dt, and the derivative of a constant is just 0. So in essence, an introduction to related rates is just taking the derivatives and adding dr over dt or dx over dt, depending on what variable you're taking the derivative of, always with respect to time. So that's the first page. We're going to move on to the second part, which is still a continuation of related rates.